Okay, I wound 5.1 ohms of winds on each of the three phases, the middle primary and the two secondaries on this bit with the X pattern shunt bars going on. And I tested this, a lot of different size caps and resistance and voltage inputs, and I can't get it to go very good at all. Maybe 25%, maybe 50%, very, very best, in versus out. And but I don't have the shunt bars wrapped with winds. So that's what I'm going to have to do next. And if that doesn't work, then there's something wrong. And what would be wrong is that I do not have the shunt bars material, the core material, the florist wire. I don't have it going all the way through. I made it on the last video. I showed how I kind of attach it on the ends with wire ties really tight, and I attach it up here, and then the transformer cores is the ring material straight, and I was thinking that's a better way to do it last time, and maybe I'm not right, and it should go all the way through. And now this one, certified a little bit over unity as far as I can tell, does have the shunt bar material going all the way through the secondaries, sharing the core with the secondaries. So there's kind of like three. There's the shunt bar material from this one coming up, and from this one coming down, and then there's the transformer ring in there. So there's kind of three layers of core material inside this secondary, and that's the way it is in both. Okay, so that's one difference between this one and this one, and the big difference is I short out these winds, and this is really pretty important. I didn't plan on discovering this or anything, but look at this. This is why it's good just to do experiments, because you find things you don't expect at all. Okay, right now I do not have the windings shorted out. I have 18 volts in and 0.12 amps. Coming out is 6.4 volts and 0.12 amps. Okay, I wrote that all down. Here's what we got. In is that much, out is about a third of what goes in. So that's pretty lousy. This is not shorted, okay? The resistive load is this 150 ohm resistor and 50 UF cap. And the resistor goes right across the cap. The secondaries go right into the resistive load, and I have one leg of the secondaries coming out, going through an ammeter on its way to the resistor that's straight across the cap. So far as I know, this is I'm checking power correctly, and so this is the out. Okay, now I'll get to it. Now I'm going to short these. I did a video before, but I didn't really show the importance of it. Okay, I'm going to pause a sec. Okay, I just shorted these all out. They're all shorted out now. The windings here, there's 2 wires from here, 2 wires from this shunt bar, and 2 from this, and there's 4 wires, and I just twisted them all together. So now it's shorted out. I haven't changed anything. It's still 18 volts input, still the same resistive load, same cap. But look at the difference now in the numbers. Coming out now is 13.3 or 2. I wrote down 3. And 0.25 and 0.26. I wrote down 0.26. That's what's coming out. Going in is, you know what it is this 18 volts. I'm going to just crank this up just a bit. I want to have the same numbers as what I wrote down. There. Okay. Big deal. 18 volts in, 18.1 volts in, and 18. 13.3 volts coming out, 0.26 amps out. Okay, so I wrote it down. When I shorted them, here's unshorted, in versus out, and look at shorted. It's a little bit over unity, a little bit. So you could say 100% efficient transformer if you want. And here it is, shorted. So that's pretty. That's really something, I think. Now, let's drop this down to 12, because I did these and wrote these down. Sorry, I'll try to make this not so boring. I don't know how. Okay. Hold on a sec. Okay. Now I have like 12.1, 12. In is this 12 times 110 milliamps, 12.1 times 110 milliamps. Coming out is 8.6 volts and 160 milliamps. This is shorted. See, it's shorted out. And this is what it is right here. With it shorted, it's a little bit over unity. A little bit. This is at 12 volts input. Unshorted. Look what it is when I take the short off the shunt bar winds. It's like 1/3 again is all you get. In versus out. Hold on 1 minute. Okay, this is not shorted out winds, just free winds. And what do I get now? 12 volts in and 0.08 amps in. And coming out now, it's 4.7 volts times 0.08. And that's this. I wrote it all down. In is 0.96, out is 0.37. 0.47, 0.08, 12.08, 12.08. So, pause one more time. Okay, shorted. 12 volts input. Now it's 0.11 amps draw. 110 milliamps. Coming out is now 8.6 compared to 4.7 unshorted, and a big 160 milliamps. It's double the current output. That's where the over unity thing comes from. It's the current. So to me, it's the secondaries are being reinforced by the opposite one. It's coming right in there and shoving it in. So there's the windings of the shunt bars, what they do. This is of great importance. And these don't have them, so I'm going to wind these, and if this one still doesn't work, then it'll be garbage. And if this doesn't work when I wind the shunt bars, then it's much better to have the secondary transformer core share with the shunt bars full length. Shunt bars go full length with them, so you have a core 3 times as thick, because you have the regular core, transformer core, which goes around, and then you also have a shunt bar coming up and a shunt bar coming down. So we'll see. So I just need to wind these, and then I'll kind of feel good that this is good or bad. Another thing different is I have 8.6, I believe, in the primary of this. 8.8 ohms in the primary and 5.3 on the secondaries. So that's another difference with this one. I should maybe have like 9 ohms set primary. And anyway, okay, so sorry about the long video, 13 minutes already, and thanks for watching.